Hey, this is OXDF, and today we're doing day 5, 2023 Advent of Code. If you give a seed a fertilizer. This is definitely the most complicated one we've had so far, so let's go ahead and take a look. I'm going to try to explain this. Basically, we're going to get this almanac, and it's going to be this thing. And the almanac has a list of seeds at the top. So I got 4 seeds, 79, 14, 55, 13. And then there's these maps for how you go seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. And so the idea is these different maps are going to tell me different ways to move from one to the other. And what I need to do, so if I take 79, let me say, so these maps, this is a starting place, a length, and a destination. So if the seed was in 98 or 99, because it's length 2, then the result would go to 50 or 51. Similarly, if it was in 50 through 98, so not inclusive, but then the result is going to be basically plus 2, because 50 goes 52, 51 goes 53, etc. So 79 is going to fall in this range right here, 50 to 98, and so 79 becomes 81. Then I can take it down to the next map and find, well, 81. It doesn't go 0 to 15, 52, so it doesn't go anywhere. If it doesn't go anywhere in the map, it just stays the same. So 81 becomes 81. I can take the 81 down here. Again, this is not going to go anywhere because 53, 8 is the biggest, and it's not going to be there. So I'm going to have 81 again. Down here, 2570, that's going to catch it. So 2570 is going to be in that range. And 25 goes to 18, so it's going to be minus 7. So 81 is going to become 74. We can just keep running this through here. 64, 13 is going to catch the 74. So it's going to be plus 8, plus 4 to get to that because 64 to 8. So 74 becomes 78. Hopefully I've not made a mistake in here. 0 to 69, 69 to 1. So it's still going to be 78. And 78 will definitely be in this range. So plus 4 is 82. And did I do that right? 81. I probably made a mistake in there somewhere, but that's the basic idea, right? You can see how these things map through. And they want to know what is the lowest location number that corresponds to an initial seed number. So this is complicated, but I think we can do it with some, I think we, if people, I imagine the fast people are going to do this with a bunch, with some just keeping state and some loops. I'm going to make some classes because this seems like a fun thing to do it. In fact, we're even going to use type hinting. So I guess we'll do that as we go. Class, we'll start here with an they called this thing an almanac. I think it's how you spell it. Let's go ahead here and we will not read lines, so we're going to get all the input. We're going to take our almanac, we're going to def under init like this, and that is going to take in puz input. And what are we going to do with the puzzle input? So we're going to take this almanac. We're going to make, let me grab, actually should grab this example almanac anyway, because we need it for example data. We can see everything is double new line enumerated, right? So we're going to, let's see, ex.text, paste this in. Let's split this to the right. This large font, I don't know how, it's kind of hard to see, but we'll go with this. What we're going to want to do here is we're going to want to get the seeds. So we can say blocks equals puz input dot split on double new line. And then we can say self dot seeds equals, and what are we going to do? So we're going to want blocks 0. We're going to split that on colon to get just the seed, the numbers. And we're going to take the back part of that. I guess we can just do 1. Then we're going to split that on new lines, and we'll have a list of strings of integers. And so we can do list map int like that, What this does is we're going to basically we're going to get these numbers, we're going to apply the integer function to that, create a list, and we're going to save it in self.seeds. Now we're going to call these things, I'm going to call each of these things a map because they're maps. And what the names of these maps is pretty irrelevant as long as I keep the order. I just got to go this way. I got to do them in order, basically. And so let's go ahead and create class map def init, and a map is going to take similarly like some lines, and it's going to return none. That's fine. And what are we going to do with our map? So a map is going to have a bunch of ranges. So we'll say self.ranges equals an empty thing. And then we're going to loop through, so we'll do for line in lines.split, a new line. In fact, and we can start on the first one because the first one's always just the label here, so we're good to skip that. We'll do that. And now for each line, what do we want to do? Well, we want to split it into the three things. We can say dest, source, and length equals line.split, like that. And we want to convert all these to ints as well. So we will do a list map int, like that. And so now, actually, I don't even know if we need a list here. I think we can do it like this. So we're going to map int and we're going to split it into those three integers. And then we can say, I'm actually going to create, we're going class heavy here. Class, and we'll call this a translation def thunder init, and the translation is going to take a let's see, we need it to take in a, I guess we'll pass the same things we had, right? So we'll do dest source length, and there we'll just say self.start equals source self dot. I think it's gonna be easier if we track this thing as well, let's see, self dot, I guess we'll do self dot length equals length. I think it might be easier, honestly, if we track this as start and end rather than length. I'm gonna do end equals source plus length, and then we can do self dot diff. Let's call it offset. That'll be easier. And we'll call that is going to be the source minus the dest. And so that's the amount we shift by if we're in the range, right? Okay, so now we've got a translation. And so here we can say like this, translations. So we can say self dot translations dot append translation, and now we just do dest source length. Okay, so now we're going to parse all of our input. We're going to end up with these series of these translations in here. And what else do we need? We also need the seed. Let's go back here and get this. If that's not part of the map, let's see. We already got the seeds. So now we need to do for b block in blocks 1 on. Again, because we're skipping the first block because it's just the seed data. We will say self.trans. Oh. I guess we'll call it self.maps. Oh, well, we can probably do this in a, let's see. Self.maps equals map block for block in blocks, like that. So basically we're going to go for each of those other blocks and we're going to turn them into a map. We're going to have our maps like that. So now we're going to effectively here, I think we've actually parsed all the data. So let's see, we can come down here and we can say almanac equals almanac. Call this puzz input. Better call this puzz input, like that. And here we have an almanac. So we can actually we'll do Python day 5. We'll do it with the -i. And that'll give us a terminal at the end. Oh, we don't like something. Oh, it helps if we give it our input. And here we can say almanac. And we can see that. We can see what the almanac.seeds is. And it matches up nicely. We can see map. We have all these map objects. We get the first one. We can see the start. Did I not have a start in a map? Let's see. First map. Oh, so the first map is the seed to soil map. Oh, so that's going to have each map is going to have a set of translations. So translations. Okay, we got that. The first one of those will have a start of 98, hopefully, an end of 100, an offset of, let's see, it should be like -48 48? Yeah, okay. Sweet. If we look at the next map, or the next translation, -2. Yeah, because we went from 50 to... So I think we've read the data in here effectively. So now what can we do? Okay, we need to push the seeds through. So we're going to come through our almanac here. And we'll call def solve self. And we're going to return... Not sure what we're going to return yet. We'll have to figure that out as we go. We will say for seed in... I better say, let's do this. Results equals this. So we'll say for seed in seed self dot seeds. We'll say res equals seed. And now we can do for m in self dot maps. We're going to take each seed and we're going to push it through each map, right? So the res is going to equal to m dot translate, which we haven't done yet, of res. We're going to take res, we're going to give it to a map. The map's going to give us the result back. We're going to store it as res. And then at the end, once we've done all the maps, we can say results sub seed is equal to res. And once we've done all of the seeds, we can return results. So we're going to have a dict here. We better from type thing import dict. Sweet. Okay, so now we need to write the map.translate function. Def translate, and this is going to take self and a number, which is an int, going to return an int. So what are we going to do? We need to take this number and figure out if it's in any of the ranges, right? So for t in self.translations, so for each translation, if we'll say like next num, we're gonna use the lowerst operator here. This is gonna be kind of cool. I'll explain that in a second. In t dot, and we're gonna need some sort of like so like trans of num, return next num. If we get to the very end and we haven't done anything, we will return num. Okay, so what we're going to do here, we're going to loop over, we're going to take our number. For each of the translations we have, we're going to check and see, does this thing translate to something different? And if so, so the lowerst operator allows you to check this and then store it in the same thing. That's what this does. And so then if this is something, we're going to return the next number. Otherwise, once we get through all of them, if there's nothing left, we'll just return the number because that's what we do. So up here in a translation, we need to do def trans self num return optional int. Better int. Trying to get better about type hinting, string. Oh, these are all int. Okay. And we need optional. Okay, so we have a translation that returns an optional int. So what are we going to do for translation? All we need to do is if self.start is less than or equal to num is less than self.start plus self.length. Oh, we don't need, we can just do self.end. So if our number falls in our range, return num minus self.offset. Otherwise, return none. That return none is actually not needed because it will return, every function returns none if you don't specify, but it makes it more readable here. So, so now if we fall in the range, we're going to return the offset thing. Otherwise, return none. And now we take that. And I think we might be done. Is that possible? Let's see what happens if we run this. We're not done. Cannot essentially type optional. Where did I do the optional? It's because you do square brackets, not let's see. I want this, but I want to get rid of the -I. Oh, it would help if I come down here. So I've got my almanac. Part none equals almanac.solve. Let's do that. We'll print the whole thing. And so you can see here we get our results. In fact, we can pull up what they have here. 79 goes to 81. I go to 82. That's interesting. So 14 goes to 43. I am not even close. 13 goes to, am I on the right? Oh, wait. 79 goes to 82. 14 goes to 43. 55 goes to 86. 13 goes to 35. The lowest number is 35. Sweet. So we can do part 1 equals solve.values like this, and that'll give me just these values, 82, 43, etc. Yep, and then we can do min like that, and we get the answer 35. Do input, and whoa, we do not like something. Almanac puzzle input, map block, invalid. We got an empty line somewhere. Probably some stripping. Let's see. Try that. There we go. Probably just a stray new line there. Let's grab this and go see if we are anywhere close. Sweet. Okay, part 2. I'm going to pause this and read. All right. This is going to be very challenging. I've been staring at this for a while. I've actually gone through and played with a little bit of code to see if I can get my head around it. Hopefully this is not like another hour-long video, hour-long from here video of me floundering. Let's see, but this looks very challenging. So basically, before, these are my 4 seeds to start with, but now in part 2, these aren't my seeds. These are pairs, so this is going to be, I will have the seeds at 79 going up 14 for a length of 14. So I'll have 79 through 93. And here I'll have 55 through 68. And I just need to do it again. The problem is, and so then I need to take all those ranges and shove them through my same set of maps and come up with the lowest one. And so for this toy problem, I could do that very easily just by, creating these as ranges and then passing them through. The problem is, we didn't go through the input at the beginning. We probably should have. My input is huge. So, these are my seeds. When I only have 1, 2, 3, 4, 5, 6, 7, there's a bunch of these, but also look, the length here is going to be in the 52 million. Here it's going to be 372 million. No, 372 million, right? So I can't do these all individually. It's too much. I have to treat these as ranges and I have to process them as ranges. And that's going to be a huge pain. So let's go ahead and try it. I am going to, this is again, probably not very necessary. we're feeling very range, I don't know what to call it, class heavy here today. So we're going to do self, and we're going to do source int, length int, and we're going to turn none, and we're going to say self. Let's grab this. In fact, we could, yeah, okay, it's fine. Self that is all we really need there. And that'll just give me a way to hold ranges nicely. Okay, so back in the almanac, what are we going to do? How are we going to start this from scratch? Well, we're not going to keep seeds. We're going to keep seed ranges, right? So self.seed ranges. And this is going to be, we're going to need to do equals, and we're going to do a range, start, length, for start, length in, can I get rid of this? And this, this is actually, I really like this now. I finally memorized it. This is the way you take, if you have a list of things in Python and you want to take them n at a time, you can always use this self-iter, self.seeds, times 2, there. And this actually is going to give me groups of 2. So in this case, it would grab 79 and 14, then it would grab 55 and 13, etc. And so it grabs those into start. We're going to loop over those pairs as start and length, and we're going to create ranges, and that's going to be self.ranges. We're not going to mess with, so that's all that's going to change in Almanac, and we're going to need a whole new solve function. So we'll say def solve to self. We'll do a dict for now. And what are we going to do? So we're going to say seed ranges is equal to, I want to make a copy because I don't want to mess with the original one. I don't know this is totally necessary, but self.seed ranges So we're gonna just do that, right? For our in self.seed range. So we've made ourselves a fresh copy. We can say for. So we're gonna do. We're gonna say for m in self.maps. We're gonna look through the maps one by one, and seed ranges is going to be equal to m.translate. If I already have a translate function, I need a new function. What do I call this one? Translate range. Maybe translate range. Seed range. So we're going to pass the range for each map. We're going to pass the range in to the map being this entire thing, and we're going to get back some different ranges that are the results. That seems pretty intuitive. Then we can return seed ranges. So down here, we're going to say part 2 equals almanac.solve2. We'll leave that for now because we can always tidy it up to get the numbers at the end. Okay, so now we need to translate range. And what this is going to be is a series of these, a map. And we're going to pass in some ranges and we're going to get some ranges out. So come down here and we'll say def translate range self. We're going to get a range in, so we'll call it input. It's hard because range is a keyword in Python, and I don't want to reuse that. So maybe we'll call it seed ranges, and that is going to be a list of range. We better import list. And we're going to take the self, and we're going to return a list of range. Okay, so how are we going to do this? I'm going to do the same thing. I'm being overly paranoid about, I don't know if this is necessary, but we're going to call seed ranges. It's going to be R for R in seed ranges, because I just want to make sure I'm not modifying something that gets passed by reference. We'll say result. Say res ranges equals nothing, so we have nothing. And so we're going to say while SRS. So we're going to have our SRS, right? And the reason we have to do this is a while, so we're going to say, well, let's see, we're going to do seed range is equal to srs.pop. We're going to get the first, so we have this thing of ranges that we need to figure out how they all map through this map. We'll get the first one or the last one, doesn't matter. We'll grab one. Now we're going to go through each of the translations, right? So we'll do for trans in self.translations. Now for each translation, we're going to have to look at the overlap, right? So the over start is going to be the max of trans.start and seed range.start, right? So the start of the overlap will be the higher start value, and the over end will be the min of the trans end, seed range end. Now, if those things, if the overlap start and the overlap, if the overlap start is greater than the overlap end, that means there's no overlap at all. So if there is an overlap, if over start is less than over end, there's an overlap, then we want to say we're going to translate that section in the overlap. So we'll say res ranges dot append. It's going to be a range. The start is going to be the over start, where the overlap started, minus the translation dot offset, right? So we're going to trans dot offset. We've mapped it through the new thing. The length. When we create a range, we're passing in the length. Length is just going to be the same length it was before. So it's going to be over end minus over start. And that is our range. Now, we pulled out some chunk of our range and we've translated it and we've saved it for later. We're done with this map, right? What's not done, and this is the part that I think is the tricky, is let's say that was, if we had a range that was like this and we pulled out this block in the middle, we still have these two pieces on the edge that could fit into other ranges. So we need to add those back to SRS. And so this is where we're going to say if seed range dot start is less than over dot start. So our seed range was not entirely covered. Then we're going to SRS dot append range seed range dot start overlap over start minus seed range dot start. basically, we're going to do that, add that. We'll do the same thing with the end. If seed range dot, actually we'll do if over end is less than seed range dot end, then srs dot append range c over end, and the length is going to be seed range dot end minus over end. And hopefully that makes sense. So basically we've pulled out some chunk. If there's an overlap, if the overlap was like the entire end, then we just pull that part off and there is nothing else to add back on. But in this case, we could add up to both. Then what I want to also need to take into account is if I don't find any, if I look through all the translations and none of them have any overlap or mapping, then I need to send the whole range, the original range, onto the result. And so what I'm going to do here is I'm going to actually put a break here, and that's going to indicate that I want to exit the for loop because I found some stuff. And then I can put an else here. So if the whole for loop happens and I find nothing, then I can do result ranges dot append seed range, like that. And so then at the end here, I can return res ranges. And I think, is that all I'm going to need? That might work. Let's try. That's not useful. Let's come up here. We can always do a, what are these ranges? Maybe kind of fun. Def repr self return string return f, and we'll do range start dash end, and we need self dot. Let's try that. So here we have some ranges. Let's grab the results and see what they were expecting. So in the example above, let's see. The location 82 leads to 46. Do we have a 46 here? We do have a 46 as our bottom range. That's feeling pretty good. What we can do then is come down here and do dot values just like we did above, and get a min here just like we did above. Try this and see if we get 46. Ooh, we don't get that. What did I do wrong here? Oh, because we have ranges. So what do we want to do? We want to do R for R in. And in this case, we'll do R dot start. And that we can do min of. Like that. Let's try that. That looks better. We got a result. All right. Again, I want to reiterate, I kind of ghosted out a bunch of this code while I was thinking about it because I thought, because I did not have a clear vision on where to go with part 2. So if this looked easy to view, this was really hard. I struggled with this one a lot. So this was a challenging problem. I suspect maybe it wasn't that, maybe it wouldn't be that hard for people who are like the who would do this in the kind of unorganized way, but I think it's valuable to do these in classes because you can start to see, it helps you just track what's responsible for what. So the almanac is responsible for the whole game. The map is responsible for a single layer and how it translates through that layer. And then even the translation and the ranges allow us to just sort of specify that. I could have probably written some sort of translation function in here, you know, in this part that did that up as part of the translation, but anyway, thanks for hanging out with me today. This was definitely the hardest one we've had so far this year. Hopefully it's not the hardest. Hopefully it stays the hardest for a while. So I'll see you tomorrow.